Hello everyone. So in class today we kind of briefly went through lessons 8 and I don't know that I even mentioned too much of lesson 11. So I wanted to give you this video so that it could help you with your homework if you were stuck on either of those lessons. So lesson 8 was something we did talk about. It's graphing a line using the y-intercept slope method. So to understand how to do that, we have to know the formula. I don't know why that keeps getting blurry. We have to know the formula of how to write a line in using this method, and it would make it easier to graph it if we put the line, the equation of the line, in this formula. So it would be y equals mx plus b. And this type of writing the equation lets us know that the m stands for the slope, and the b tells us where the line crosses the y-axis. So it's the y-intercept. So if you recall, the y-axis is the one that goes up and down. This is y and this is x. So if we have an equation that is already written in this form, we're going to say y equals negative 3x minus 3. So let's go ahead and put some numbers on our number line. We're putting, this is the negative numbers on the x, these are the negative numbers on the y, and these are the positive numbers on the y. Okay, let's look at this equation. We want to first try to figure out where the line is going to cross our y-axis, and that's what b is. In this line, in this equation, b is negative 3. It's always the last number in the equation, and you always have to look at the sign right before it. So in this line will cross the y-axis at negative 3. 1, 2, 3. So we put a dot right there. Now we have to find the slope. We have to tell which way the line is going to go. Is it going to go this way or this way, etc. So our slope is m. The slope is the coefficient, which just stands for the number that comes before the x variable. So the coefficient of x is negative 3. We always have to make sure that we're watching those signs. So our slope equals negative 3. What does that tell us? I think you all said in class that you heard of rise over run. That's another way of writing the slope. This slope is negative 3. So we need to write negative 3 as a fraction. To write negative 3 as a fraction, we put negative 3 over 1. Because negative 3 ones is the same as negative 3. So that means the rise is negative 3, which means the line is actually going to slope downwards because of this negative sign tells us that. And the run is how far the line goes this way, is a 1. So we're starting at our y-intercept. We're going to go 3, which is our rise. And because it's negative, we're going to go down 3. So we're going to go 1, 2, 3. And then from this point, we need to look at what our run is. A run is a positive number, so we're going to go over 1, and that's going to put our dot right there. So our slope of this line means for every time it goes down 3, it goes over 1. So now we have this dot, and I forgot to grab my ruler, but taking a ruler, you would go ahead and connect those two dots, and that is the equation of this line. So I want to show you another one so that you can see what you would do if your line is not written, if your equation is not written in the y-intercept method. So if we have 2x plus 3y equals 6. And as you can see, it is not written in this format. So we have to first rewrite it. So how do we do that? We want to get only y on this side of the equation and everything else on the other side. So first we're going to subtract 2x from each side, which gives us just 3y on this side and 6 minus 2x on this side. We still have something else over on this side of the equation. We have a coefficient of y, and we only want y. So we have to divide each side by 3. And when we divide this side by 3, we have to take each of these each of these expressions and divide them by 3. So now let's rewrite it. The 3's cross off, and we get y. 6/3 equals 2 minus 2x over 3. It still doesn't look in the same format because we have our x over here, and it's part of a fraction when we want it only by itself. And we have our b in front of it. So we still have to change this around. We have to, let's first switch these two around. So we have to remember to keep the sign. So in order to put this part first, we have to keep the negative sign. Otherwise, it changes the expression. Now we have minus 2x over 3. And we have to decide whether we're going to add 2 or subtract 2. Well, it's a positive 2, so we're going to add 2. Now we're close. We have the y by itself. We have our y-intercept clear, but our slope isn't quite clear. We have to remember that minus 2x over 3 is the same thing as a negative 2/3 times x. These two expressions mean the same thing. And when we rewrite negative 2x over 3 like this, negative 2/3 x, we can clearly see then that the slope, which is the coefficient of x, is negative 2/3. It's just easier to see it if we rewrite it that way. So we have negative 2/3 x plus 2. Now we're ready to graph because we have this written in our correct format. So we make our y-axis, we make our x-axis, and we put a few numbers in on both sides. This is 1, 2, 3, 4, etc. Now we're going to put a few numbers on our y-axis and a few on our y-axis in our negative part. So where do we start? We look and see, where does this line cross the y-axis? That's what the y-intercept means. That's what B stands for. It crosses it as a positive 2. This one has a plus sign in front of it. Our last y-intercept had a negative sign. That's why it crossed the axis and not in the negative part. Crosses at 2, so we go up 2 and put our dot. Now we look at the slope. We have negative 2/3 x. Negative 2/3. Rise over run. So for every time this line goes down 2, it goes over 3. The negative sign tells us to start at this dot and go down 2, 1, 2, and then we need to go over 3, 1, 2, 3. So we put our dot here. And like I said, I'd like you guys to do this with the ruler. I just forgot to grab mine. But here is what the equation of this line would look like. So that's the answer that you would put in your book. So that's why I want you to use the graph paper. Okay? So very quickly then, I want to move on to chapter 11. Chapter 11 talks about adding fractions. And we're going to add fractions that have variables in the denominator. So let's do this one first. We have 3 fractions. We're going to add k over 2a plus bc over ax squared minus m over ax cubed. Okay, the first thing that you want to do when you are adding or subtracting fractions is we have to find a common denominator. I'm sure you remember that, like if we wanted to do 3/4 minus 1/3, before we could do that, we would have to find the common denominator of 4 and 3, which would be 12. How do we find the common denominator of 3 expressions that have variables in them? The first thing you want to look at is we're going to look at the coefficient of each expression. The coefficient just means the number that is before the letters. The letters are called variables, and the numbers in an expression are called coefficients. Just so that you know what terms I'm using. Okay, so in this problem, we only have one coefficient. The only expression here in the denominator that has a coefficient is this 2. So we know we're going to have a 2 for our common denominator. Now we want to look, this first fraction has an a in it. This one does as well, and this one does as well. They are all the same. It's a to the first power. It doesn't have an exponent, so they're all a. So we can just put an a down here. And then next we have to see if there is anything else in the denominators that we haven't taken account down here. This one is all set. This one has an x squared, and this one has an x cubed. The least common multiple, which just means the number that both of them will go into, the smallest number that both x squared and ax cubed will go into, is ax cubed. Because if you take ax cubed and divide it by x squared, that gives you an x. It goes in evenly. So here is our least common multiple. This is the number that 2a can be divided in evenly, ax squared can go into this evenly, and ax cubed can go into this evenly. And this is the smallest number that each of these things can go into evenly. So now we have our common denominator. Now we need to put that on the bottom of all three of our fractions. And remember to subtract this one. We have to watch those signs. This is going to run into this, so I'm going to just cross it off for you so it doesn't get confusing. Okay, so we have 2ax cubed under each of our three fractions now. So now we have to find an equivalent fraction. We have to do k over 2a. We have to find an equivalent fraction that has this denominator. Let me write that down here so it's a little clearer what I'm saying. We have k over 2a, and we want to change it to a fraction that has 2a cubed on the bottom. But we want to make sure that they remain equal because we don't want to change the problem. So we have to look, what do we multiply 2a by to get 2ax cubed? Well, we multiplied the bottom by x cubed to get this. If you multiply the bottom, the denominator of a fraction by something, in order to keep it equal, you have to also multiply the numerator by the same thing. So this was multiplied by x cubed, so we need to multiply the top, the numerator, by x cubed. And we get kx cubed. So kx cubed over 2ax cubed is the same thing as k over 2a. So we're just going to rewrite that up here. So now we have kx cubed. Now we're going to do the same thing with this one. What do we multiply? We want to change bc over ax cubed into a fraction that has 2ax to the cubed as its denominator. So we're going to look and see, what did we multiply this by to get this? Well, we need to multiply this by 2 to get this 2, and then this x squared, we need one more. So we need to multiply this bottom by 2x in order, ax squared times 2x will give us this. So if we multiply the denominator by 2x, that kind of looks like a y. Multiply the denominator by 2x, we have to multiply the numerator by 2x. And when we do that, we get 2bcx. So bc over ax squared is the same as 2bcx over 2ax cubed. So we'll put the 2bcx on top. We have one more to go. We need to change this fraction into this fraction. If we look, ax cubed, to get to this denominator, 2ax cubed, we multiplied it by 2. So multiplying this by 2, we need to multiply the numerator by 2. M times 2 is 2m. Now we are almost set. Just like you can, if we had a problem where I had 1/8 plus 4/8 minus 3/8, all you would have to do, we have 1/8 plus 4/8, that gives you 5/8, and then we subtract 3/8, we would get 2/8. So notice in this problem, the denominators all stayed the same. That's why you find a common denominator. And then you simply add and subtract the numerators. We did 1 plus, if I write it out like this, we did 1 plus 4 minus 3 all over 8, which gave us 2/8. That's how you would do it with numbers. So that's the same thing that we're going to do with our variables. We are going to notice that these denominators are all the same. So our answer is going to have 2ax cubed as the denominator. Now, what do we do with the numerators? We have to add kx squared plus 2bcx. Remember, these are not like terms. It's like apples and bananas. We cannot add them together, so we have to keep them separate. So we're going to say kx cubed plus 2bcx. Watch the sign. We have to remember to watch the sign. Just like in this problem, 1/8 plus 4/8 minus 3/8. In the numerator, we did 1 plus 4 minus 3. We have to do that the same here. So we're going to need to subtract this last numerator, which is 2m. None of these are like terms. So that's the most simplified that we can get this answer. So this becomes your answer right here. So the answer to k over 2a plus bc over ax squared minus m over ax cubed is kx cubed plus 2bcx minus 2m all over 2ax cubed. So that's how you do those problems. I'm going to do one more, and I'm going to do it a little bit more quickly since we already went through one. If we have m over k minus b plus cx over ak squared. What I want you to remember about these is if we have a variable that does not have a numerator, we simply put it over 1 because we want to make sure that we have 3 fractions. Now we're going to look at the bottom here. We have to find a common denominator between k, 1, and ak squared. What's the smallest thing that all 3 of those can go into? Well, we're going to need an a because ak squared needs to go into it. So we're going to start with that. And then we're going to look at these k's. You have to find the one that has you take the one that has the largest exponent, and that's what you use. So k squared. So this becomes our common denominator. K can go into ak squared evenly, and obviously ak squared goes into ak squared. It goes in 1, and 1 can go into anything. So all 3 of our fractions are going to be rewritten with ak squared on the bottom. Okay, so we need to make m over k equivalent to something with ak squared in the denominator. What do you multiply k by to get ak squared? You multiply it by a times k. So we have to also multiply the m by ak, which gives us m a k. Now we have to change this b over 1 into a fraction that has ak squared on the bottom. You multiplied 1 times ak squared, so we need to also do that to the numerator, which gives us bak squared. This one's easy. It already has ak squared as the denominator, so we don't do anything at all to the numerator, we just copy it. Now we're all set. Now we can go ahead and see what our answer will be. Remember, the denominators stay the same, just like when we did 1/8 minus 2/8, etc. So the ak squared will be on the bottom. I'm going to write it down here because the numerator is too big to fit in there. AK squared is the denominator. Now we need to look and see we have no like terms in the numerators, so we're just going to have to write them down here. We start with MAK, then we watch the sign, it's a minus. We take our BAK squared and write it next. Watching the sign, we add the last one, which is CX. That is how you would add these three fractions, add or subtract these three fractions by first finding a common denominator and then writing the answer like that. Good luck.